Hello everyone, this is Hating Tian. This video we are learning 2.1 Parametric equations. In college algebra, we learned the equations. If I have the equation, I can find the points on the equation. Plot the point on the xy plane, connect them. We can find our graph or the functions graph. All right. For example, if I have a point x comma y, this point is on my function. I can find the x value. Pick some x value. For example, I can pick -1, 0, and 1. By the function, I can find the y's value because y's value is equal to f of x. So I can find the x comma y's value. Now, in the parametric equation, my x and y's value, they are functions. So x is f of t, and the y is g of t. So I can write them vertically like this. X is equal to f of t. Y is equal to g of t. T is perimeter. I can also write them horizontally. So we say x is equal to f of t, y is equal to g of t. So x follows this function, and g is following this function. Okay, let's see the example. For the following, sketch the curve, indicate the orientation, and eliminate the perimeter to get the equation involving just x and y. So let's first sketch the curve. If I want to sketch the curve, I can plot the point. What is the x value? What is y's value? So x comma y. So x comma y. Find the point on the xy plane. I can graph my function. Okay, so how to plot the point? We need to find the x value and y's value. So the t value is given. It's a bounce between -2 and +3. If I know the t's value, for example, t is -2, can you find the x value? Yes, I plug it into my first equation. If x is equal to -2, then plug it into the second equation, I can find y's value. Then I have x comma y. That is my point. Plot the point. I can find the graph. So let's list the table. Let's make a table. This is x value and this is y's value. And the first column, let's put the t here. I can choose the t's point, and then I can find the x and y's value. So starting from the smallest number of the t is -2. So what is the next? It is -1. I can pick some integers. 0, 1, 2, 3. So how about the x and y's value? Use the first equation. Let's say this is first equation, second equation. From the first equation, x is equal to t's value squared minus 3. First t, I chose -2. -2 squared minus 3. It is 4 minus 1 is, 4 minus 3 is 1. What is the y's value? Y is from the second equation is 2, let's see, y is 2 times parentheses minus 1. So now first t is -2. So 2 times -2, -4, minus 1 is -5. Okay, my first point is 1 comma -5. And let's start to find my second point. Plug in t is equal to -1 here and here. Find the x and y's value. Okay, I can put -1 here. And then this is -1 squared minus 3. Okay, it is -2. So what is the y's value? Put the -1 here. -2 minus 1 is -3. So my second point is -2 comma -3. Let's use the formula. I can erase this. So let's use this formula to find more x and y's value based on the t, the increasing t. Okay, so I'm having -2, -3. So -3, -1, and -2, 1, and 1, 3, 6, 5. The first point, or the initial point, it is my t equals -2. So first point is 1, -5. Where is the first point? 1, 1, 2, 3, 4, 5. Here, 1, -5. This is the t equals -2. How about the second point? -2, -3. -2, -3. This is t equals -1. Next point is -3, -1, and -2, 1. 1, 3, and 6, 5. Let's plot the point. So t is equal to 0. The x, y's value is -3, -1. And the fourth point is -2, +1. And the next point is 1, 3, 6, 5. 1, 2, 3, 4, 5, 6, 4, 5. Yes, let's use curve to connect them. Initial point. So let's use the red color to highlight the initial point. So initial point, and going this way, and then going this way. It seems like the portion of our problem. So what is the next? Is asking you what is the orientation. Okay, I'm coming from the initial point, going this way. So this orientation, we can say from the bottom to the top. Okay, so how about next part is eliminate a parameter to get an equation involving just x and y. And how to eliminate the t, parameter t? List the equation only have the x and the y's value. List the equation between x and y. So we can use the substitution method. So from here, okay, let me highlight the relationship. The equation. How to list the relationship between x and y? We can use substitution method. We are selecting the easy equation. I'm selecting the second one, number 2, because the second one, y equals 2t minus 1, is a linear equation. Seems easier. So if I'm picking my second equation, which is y is equal to 2t minus 1. So next step is isolate the t. So leave the t alone. We should +1 both sides, and then divide it by 2. Y plus 1 is 2t divided by 2. So y plus 1 over 2 is equal to t. Now t is equal to y plus 1 over 2. And then bring the t's value to the first equation. So x is equal to t squared minus 3. Now we are having y plus 1 over 2 squared minus 3. And next step, oh, sorry, I have a mistake. So here, x has no squared, just the x is equal to y plus 1 divided by 2, all of them squared, minus 3. All right, let's rewrite it because we want to rearrange it or relocate them. So we can move the 3 to another side. We can plus 3 both sides. X plus 3 is equal to y plus 1 squared over 2. Okay, I have a problem. Let me ask you. Can I distribute my square top and bottom? Yes, I can square the top and square the bottom. X plus 3 is equal to y plus 1 squared over 4, because 2 squared. Let's multiply by 4 both sides. We have 4 times x plus 3 is equal to y plus 1 squared. Let's swap the two sides. We're having y plus 1 squared is equal to 4 times x plus 3. So, what did you see this? So, do you remember we have y minus k squared is equal to 4a times x minus h. This is parabola. Yes, why I want to do this? I'm relocate or we reorder everybody because I see the shape here I have sketched is very similar like my parabola, the portion of the parabola. Let's rewrite it if I can make a parabola. And in this equation, so in this equation, what is the vertex? It is -3, -1. Let's prove. Yes, this point is -3, -1. And what is A? A is positive 1. We'll use 4 divided by 1, divided by 4, it is 1. And 1 is positive, so my parabola is open to the right. Okay, so this is a portion of our parabola because the t has restriction. If t has no restriction, this is just a parabola without the let's see example 2. Consider the parametric equation. X is equal to sine t over 2 and y is equal to cosine t over 2. Find the point x, y on this curve corresponding to t is equal to 2 pi. Okay, this question is just looking for the point x, y, and then how to find x, y. So we have the x is equal to sine t over 2. And now the t's information is given. T is equal to 2 pi. So we have sine 2 pi over t. It is sine pi. What is the sine pi? Sine pi is 0. And the y's value, sine t, cosine. It is the cosine t over 2. And given information is t is equal to 2 pi. So 2 pi over 2, it is cosine pi. And what is the cosine pi? -1, -1. So 0, -1 is my point on this curve. If you want to graph it, we need to plot more points. Okay, so let's move on to next example. The pair of parametric equation represent a line, parabola, circle, ellipse, or hyperbola. The following examples, they represent the line, parabola, circle, ellipse, or hyperbola. Name the type of the basic curve that each pair of equation below represents. This question, it doesn't ask us to graph it. And also the t doesn't have a restriction. They want to find the equation between x and y. So finding the relationship between x and y, they are all connected with the t. So we should isolate the t first from one of the equation. So now we have two equations. Pick one easy one, and then plug it into another equation. And then we can eliminate the t. So first step, I will choose one I feel easy. I feel these two, they are all linear equation. They all looks easy for me. If I start from the first one, if you start from the first one, second one, you have the same relationship between x and y. If I'm starting with the first one, so isolate the t. X minus 3 is 4t divided by 4 both sides. X minus 3 over 4 is equal to t. And bring this equation, or bring the t inside of the second equation. So y is equal to -4 multiplied by new t, which is x minus 3 over 4. Let's do the cancellation. 4 canceled. y is equal to negative x minus 3. Let's distribute the negative 1, negative sign, x plus negative x plus 3. This is a linear line. So we say this is a line. You can graph it. For example, I can pick some point for the x and y. For example, x is, you can also put the t back. So if the t is equal to 0, and the x and y's value can be found from these two equations. So they are x is equal to 3, y is equal to 0. I can also plug in the t's value is equal to 1. So x is equal to 7, and the y's value is negative 4. So 2 points can decide a line. So 3, 0 is here, and let's say here. And 7, negative 4. 7, negative 4 is here. Okay, connect them. This is my linear line. All right, let's go on to see next example. If the question didn't ask you, can you graph? You don't have to graph. You just say this is a line. Number B, if I have this parametric equation, I want to convert it to one equation, only have the x and y without the t. Let's eliminate the t. So the two equations, they are number 1, number 2. I'm choosing number 2 because it seems very easy. And number 1 has a squared. So we should isolate our t from number 2. Y is equal to t plus 5. Let's minus 5 both sides. Y minus 5 is equal to t. T is isolated. And then we should bring it to the first equation. X is equal to 6 times t. So t has been replaced by the y minus 5. So we have this equation. The question says you need to decide the name of your equation. For example, the shape of your equation is a parabola, ellipse, hyperbola, or a line. So this is not a line. Line must have, this is not a line because the line cannot have the squared. And the x, y, they are has the first power. Okay, so what do you think? It seems like a parabola. So what does a parabola look like? If I have the y part squared, I need to have the y minus k squared isolated. Another side is 4a times x minus h. So let's rewrite my equation with the isolated y squared, or y minus k squared. So let's plus 4 both sides. We're having x plus 4 is equal to 6 times y minus 5 squared divided by 6 both sides. We have 1 over 6 times x plus 4 is equal to y minus 5 squared. And now I can let the y part on the left hand side. Y minus 5 squared is equal to 1 over 6 times x minus 4. Plus 4. I can tell the vertex is h comma k and the a. So 4a is 1 over 6. I can find the a. So a is positive and y part is squared. So I'm having my parabola like this, open to the right. All right, let's see next example. Oh, we should put the name of the equation here. Okay, let's see next example. So this parametric equation, how to eliminate the t and then find the relationship between x and y. So it's hard for us to isolate the t from one of the equation. But we have learned this. If I have the sine theta squared plus cosine theta squared is equal to 1. And it doesn't matter what is my theta. The theta could be 2t, or it could be 3t, or it could be 300 degree. And then they have this relationship. That means I can isolate the cosine and sine from both of the equation, from the equation 1, equation 2. So from the first equation, let's isolate the cosine 5t. So x is equal to 2 times cosine 5t divided by 2 both sides. So cosine is isolated. X over 2 is cosine 5t. And from second equation, y is equal to negative 6 times sine 5t. Let's divide it by negative 6 both sides. Y divided by negative 6 is equal to sine 5t. So cosine squared plus sine squared is equal to 1. We can list this equation. We say cosine 5t squared plus sine 5t squared is equal to 1. Then I can plug in the y and x and y's value. Cosine 5t is x over 2. Then we square it, plus y divided by negative 6 square it is equal to 1. Let's separate the top and bottom. So square the top, square the bottom. Square the top, square the bottom. So negative 6 squared is just a 6 squared is equal to 1. What is this? Is this a circle? No, circle, the bottom must be the same. And this has an addition sign. This is an ellipse. So we can write this is an ellipse. And with the center at 0, 0. And then where is the A? We don't have to write all of this information. But we can review a little bit. So A is under the Y. So my graph main axis is parallel to the y-axis. This is the shape of my ellipse. All right, let's move on to see the number D. The same thing. The relationship between the sine and cosine. The Pythagorean theorem is sine t squared plus cosine t squared is equal to 1. Let's isolate the sine and cosine from two equations. From the first one, x is equal to 3 sine t divided by 3 both sides. So x over 3 is equal to sine t. From second equation, divided by 3 both sides, y is equal to 3 cosine t. Divided by 3 both sides, we have y over 3 is equal to cosine t. So cosine t, sine t squared plus cosine t squared is equal to 1. We just bring the sine and cosine in this equation. So we're having x over 3 squared plus y over 3 squared is equal to 1. And then we can square the top and bottom. X squared over 3 squared plus y squared over 3 squared is equal to 1. So we have the same bottom. The bottom are the same. That means this is a circle. So we just say circle. And the center is at the origin. And what is the radius? So since the bottom is 3 squared, r is 3. Is a circle with a radius 3. Okay, let's move on. So here, this part, you can pause the video and read the instructions. How to graph on the paper, how many steps, and then graphing on my open math. Okay, later I will record one question when you are graphing on my open math and how to graph the shape, graph the parametric equations. All right, let's go. So example 4, for the following, find the equation. Oh, I think the previous part we find the graph first. Now they ask us to find the equation first. And then sketch the curve. indicates the orientation, left to right, right to left, counterclockwise, clockwise, counterclockwise. So let's see the first one. Okay, find the equation. We have two equations. Now they are horizontally listed, but it's okay. Oh, now I see there is a restriction for the t. We need to be very careful. All right, let's eliminate the t. This is my equation 1, this is my equation 2. I can start from either one because they are all linear equations. So I cannot say which one is easy, which one is complex. It looks the same. So if I'm using the first one to isolate the t, x is equal to 4t minus 3 plus 3 both sides. Let's make a lonely t. X plus 3 is equal to 4t divided by 4. So the t is isolated. Then from the second one, we bring this t into the second equation. So y is equal to 6 times the t is x plus 3 over 4 minus 2. Let's distribute the 6. Y is equal to 6 and 4, they are all divisible by 2. So I have 3 here, I have 2 here. So 3 over 2 times x plus 3 minus 2. I can distribute the 3/2 in the parentheses, or if you list it like this, it's okay. You get the full credit. If you want to rewrite it to the slope-intercept form, it all depends on the question. If the question says, rewrite it into the slope, y is equal to mx plus b, you should distribute. If it didn't ask you to distribute, keep it like this. So if I want to distribute, y is equal to 3/2 x plus 9 over 2 minus 2. Combine the 9/2 and 2, we're having 3/2 x. Then we plus 5 over 2, mx plus b. Now let's make a sketch. So before we make a sketch, we should have a table. The first column of my table is t, second column is x, and y. I can find x, y, x, y. And finding the t's value, it gives us the restriction of the t. So let's start from the -1. T is equal to -1, 0, and 1. You can pick other numbers like 0.5 or 1/4, but I pick the easy numbers. For the x, find the x from the first equation. From the equation here and the equation here. It's a little bit messy. So the x value is 4 times -1 minus 3. Do the computation, -7. And the y is equal to 6 times -1 minus 2, -8. And then bring the 0 inside, we have -3, -2. And bring the 1 inside, we have 1 and 4. So the 3 points, they are -7, -8, -3, -2. Actually, this is a linear line. We found it from the equation. We don't have to find too many points. 2 are enough. So if you don't want to, two points can decide a line. And in this question, we got 3 points. And which point is our initial point? Is -7, -8. So this is my first point. Do I have any point that is the t less than -1? For example, -2. T cannot be -2. So this is my first point. Okay, and what is the next point? -3, -2. So -3, -2. For example, it is the point here. What is the next one? Is 1, 4. So let's say maybe 4 is here. Okay, let's say 3 points. All right, starting from the initial to the second point to the third point, or we say this is the end point because these two values of the t are my two endpoints. I cannot have other points other than these. Actually, when you graph it, you just need these 2 points. Connect them. This is my linear segment. Sorry. So you don't have to have the third point in the middle. The two endpoints, they are very important. Okay, what is orientation? I forgot to decide the orientation. Orientation is where is my segment going? Is from initial to the terminal point. So I think we can say this is from the left to right. Okay, let's see next example. This example, we want to describe the relationship between x and y. So we can eliminate the t. So we can say this is my equation 1, equation 2. Where I should start to do the elimination, I'm starting from the 2. You can also start from the from the 1. We have the same expression. So from the 2, we have the same graph. Sorry. From the 2, y is equal to t plus 2. So t is y minus 2. Bring it to the first equation. X is equal to y minus 2. So, y minus 2 squared. This is the, make a sketch. This is a parabola open to the right because the y part is squared and the a is positive. And I can find the vertex, I can graph it. But the t has a restriction. I cannot say this is the full image of my parabola. Maybe it's a partial of our parabola. So let's see how to graph it properly with these restrictions. So we have t in the first column, x in the second column, and y in the third column. For the t, I can pick some easy values. For example, t is equal to 0, starting from 0, and 1 and 2. So find the x value, bring the 0, t equals 0 in the first equation. T squared, 0. Second equation, t plus 2, 0 plus 2. The point is 0, 2. Second one is t is 1, so x is equal to 1. T is 1, t plus 2, 3. Third point is t is 2, x is equal to 4, and t 2 plus 2, 4. So the 3 points, 0, 2, 1, 3, 4, 4. We have 3 key points. Initial point is 0. I'm starting from my first point. So initial point is 0, 2, starting from the first point. And then use a smooth curve, connect the second point and the third point. And there is no bound, so we can keep finding, so we can keep our curve moving forward without the end point. Okay, let's draw a xy plane. First, find 0, 2, and then 1, 3, and then 4, 4, 4. So let's connect it. So this is a square root function. And also, this is a half of our parabola. You can also say half of our parabola. Okay, we're done this question, but some of you say, teacher, I started my finding the equation between the xy from the equation 1. Yes, we can also do that. For example, if I did this, we say way 2. You started from the first equation, eliminate the t from, so do the substitution from the equation 1. We are having x minus t, x is equal to t squared, square root of both sides. So square root of x is equal to t. Why I do not have a plus or minus sign here? Why I don't have plus or minus sign? Because Here, x is greater than or equal to 0, I cannot have a negative sign. Here, I can only have positive square root of x. And x is also positive because x is equal to t squared. So x is also positive. And then bring it to the second equation. No, sorry. Y is equal to square root of x plus 2. Even my expression here doesn't have a t and has different expression like this. But we still say they are the same because they represent the same thing, which is the square root function or the half of the parabola, because half of the parabola is the square root of function. In college algebra, we have learned y is equal to square root of x is the square root of function. And if we plus 2, we did the vertical shifting, move up to unit. So if you gave me these two, either one of the expression, you get the full credit in your exam. All right, you can say this is a square root function or the half parabola. Okay, next step, you just use the same table. You have the function, the points x comma y, plot them and connect them with smooth curve. And what is the orientation? We can say is starting from the left to right, because from the initial point is here 0, 2 and all the way this way. So this from left to right. Okay, let's see number C. Where I should start. I always want to start my elimination from the easy equation. So I think the second one is the easy equation. So this is my first equation, second equation. Let's start from the 2 because it looks easier. So y is equal to t plus 1. We isolate the t is equal to y minus 1. Bring it to the first equation, x is equal to y minus 1 squared plus 2 times y minus 1. Oh, this one, maybe we need to have more computations. Let's see, expand the x minus 1 squared. This is the perfect square trinomial. You can also have x minus 1 times x minus 1, do the distribution. Or you just use a perfect square trinomial to FOIL it or to express it as a y squared minus 2y plus 1 plus distribute the 2y minus 2. And then combine like terms. I missed the one term. Okay, plus 2y minus 2y is 0. Plus 1 minus 2 is minus 1. X squared is equal to y squared minus 1. What is this? Okay, we need to reorder it until we see this is the graph we are looking for. So we can move the x and y together. Oh, I know where's my problem. When I bring it down, I have a 2 here. We don't have to have a 2. If we have a 2, I should say this is the hyperbola things, but we don't have a 2, sorry. Okay, so from this one, x has no squared, y has a squared. This is my parabola. So we have the restriction. I cannot say this is the whole image of my parabola. Maybe it's a partial of my, or portion of my parabola. Okay, from this we can start to graph my function. So first I need a table. First column t, second column x, third column y. And then we can have our several points. Maybe we can have 2 or 3 points. Starting point is t is equal to -1 and t is equal to 0. Let's say t is equal to 1. And the x comma y's value. When the t is -1, x is equal to, from the equation 1, -1 squared plus 2 times -1. Do the computation. 1 minus 2 is -1. and the y's value is -1 plus 1, 0. So 1, comma 0. And next xy's value for the t is equal to 0 is 0, comma positive 1. And next points x, comma y. It is 1 plus 2, 3. And then 1 plus 1, 2. 0, comma 1, 3, comma 2. I can find the points starting from the initial points 1, comma 0. So where's 1, comma 0 is here. And second point is 0, comma 1. Let's see, 0. Do I have any computation mistake? Oh, okay. I found my mistake because I'm thinking my second point is 0, comma 1. I'm going this way. But this image tells me, I should have my graph looking like this. So that's so weird because I copied something wrong. So here is -1. I have positive 1 here. Let's get our first point. -1, comma 0. So -1, comma 0 here, 0, comma 1 here, and then we say 3, comma 2 is here. Yes, looks much better. Okay, so this is the half of our parabola. You can say this is square root function. You can also, this is the half of parabola. Okay, so what is orientation? Is from the left to right. You can also say this is a square root function. Okay, let's see next example. Okay, so before we move, you see this one is not the standard form of the parabola. We can also rewrite it. So the square root parabola, the standard form of the parabola, we should have the y isolated with +1 both sides, x minus 1. We can box them because I want to find my 4a. My 4a is 1, and you can find the vertex, which is 1, comma 0. Okay, sorry, -1, comma 0, because we need to add 1 both sides. Okay, let's see number D. So this one, can I eliminate the t, perimeter t, by rewriting one of the equation? No. So if we find the t, cosine and sine, we're using the sine t squared plus cosine t squared is equal to 1. Pythagorean theorem to find our new equation between x and y. So from 1 and 2 equation, let's isolate the cosine t and sine t. From the first equation, x is equal to 3 times cosine t minus 1. We can plus 1 both sides. 3 times cosine t, and then divided by 3 both sides. So x plus 1 over 3 is equal to cosine t. Second equation, y is equal to 2 sine t plus 2 minus 2 both sides. And then divided by 2, this is a sine t. Now we plug them into this equation. We can have the cosine first because we found the cosine first. We say x minus 1, plus 1 over 3 squared is plus y minus 2 over 2 squared is equal to 1. I can separate the top and bottom. Square the top over 3 squared plus y minus 2 over 2 squared. Okay, I forgot the squared on the top. What is this? This is an ellipse. And then we can find the center is -1, comma 2. What is the a? So a is 3 or 2. It is 3. 3 is a big number. So we say a is 3. Then I'm having my ellipse. the main axis, major axis is parallel to the x-axis. Do I need to graph it? I think so, because the question says we need to graph it. Let's move this one to the top. We have more space. Okay, let's list the table and find our graph. Before we list the table, we know that this is a ellipse, and we have the shape like this because 3 is greater than 2. 3 is A. The major axis is parallel to the x-axis. Okay, let's list the table to find the specific points. So the first column is t, second column is x, third column is for the y. And for the t, I can pick some number between 0 and 2 pi, including the initial point as t is equal to 0. So we say 0, and I really want to pick some easy points. Let's say pi over 2 and pi. So some easy number, let's say 2 pi. And then what is the x value based on these 4 t's value? T equals 0, so x is equal to 3 times cosine t minus 1. If t is 0, cosine is 1, 3 minus 1, which is 2. And then the y's value is 2 times sine 0 plus 2. So sine 0 is 0, 0 plus 2 is 2. So first point is 2, 2. And then second, 3 times cosine half pi. So cosine half pi or pi over 2 is 0. So 0 minus 1, negative 1. And then what is the y's value? So 2 times sine half pi. So let's see, sine half pi is 1. 2 times 1 plus 2, 4. So negative 1, 4. And then, so t is equal to pi, 3 times pi. T is equal to pi, 3 times cosine pi. Cosine pi, negative 1. 3 times negative 1 minus 1 is negative 4. So negative 4. Y is equal to sine pi, pi is 0. 2 times 0 plus 2 is 2. And then 2 pi. X value 3 times cosine 2 pi. Cosine 2 pi is 2. And then, cosine 2 pi is 1. 3 times 1 minus 1 is 2. And then y's value 2 times sine 2 pi is 0 plus 2, 2. So we have 4 points. They are 2, 2, negative 1, 4, negative 4, 2, and 2, 2. Initial point is 2, 2. Let's graph our function. Here is the xy plane. Center. Do I need to have the center? Yeah, maybe we can have our center from our equation, which is negative 1, positive 2. Negative 1, negative 2 here. Oh, sorry, positive 2, what I'm saying. Yes, this is positive 2. This is negative 1. Yes, I found my center of an ellipse. And then second, let's find our first point. Our first point is 2, 2. So 2, 2 is here. And the second, let's find 1, negative 4. Negative 1, positive 4. Sorry, it's here. Negative 1, positive 4 is here. So connect them with smooth curve, and you can tell this is the orientation. And then third point is negative 4. Let's find negative 4, positive 2. Okay, here. And third point, next point is 2, 2. Okay, I ignored some points. So we should have our graph like this. 2, 2 is my fourth point. So what I'm doing, I'm rotating my graph clockwise. So the orientation is counterclockwise. And this is an ellipse. All right. Let's see next example. I will let you try, but I will also show you how to do it. Okay, first I identify the cosine and the sine. That means maybe is also a circle or ellipse. And then, so let's prove what is the shape of my function, parametric function. So first, let's start from my number 1, the equation 1. Isolate the cosine t. Cosine t is equal to x minus 3, and from the second equation, sine t is equal to y plus 3, and then we say x plus 3 squared plus, minus 3 squared plus y plus 3 squared is equal to 1. Oh, this is a circle because under them it is 1, or you say 1 squared. So this is a circle, and the center is at 3 comma negative 3 is coming from the h comma k. And then next we can list a table. I can find the point t, x, and y's value. So when the t is equal to, what is the initial 0? Terminal is 2 pi for the t. So t is equal to 0 here. Maybe we just list the 3 points and 2 pi. And the x value, let's come to the first equation here. So x is equal to 3 times cosine 0. Cosine 0 is 1. So x is equal to 4. And what is the y's value? So y is equal to negative 3. So 4 comma negative 3 is my first point. When the t is equal to pi, okay, cosine pi is negative 1. So 3 minus 1 is 2. And the y's value is negative 3 plus sine pi. Sine pi is 0, negative 3. So 2 comma negative 3. Next one, let's find the x comma y. T is 2 pi. X plus cosine 2 pi is 3 plus 2, 5. And then y's value, negative 3 plus sine t, sine 2 pi. So sine 2 pi, my daughter is back. Okay, sine 2 pi is 0, negative 3 here. I'm thinking I have some typo or mistake somewhere, because when the t is 0, when the t is 2 pi, they must have the same cosine and sine value, because for the cosine t, sine t, 1 revolution, they are all 2 pi. Why my x value, y value are different? Okay, let's check where is my mistake. Okay, if I'm looking at the t is equal to 0, x is equal to 3 plus cosine 0. And cosine 0 is 1. So 3 plus 1 is 4, no mistake. And how about my second? So when the t is 2 pi, 3 plus cosine 2 pi. So it is 3 plus 1. It is 4. I cannot have a 5. So let's replace the 5 with 4. Okay, I got a lot of information. Let's start to graph. 4 comma negative 3. First, I know the center must be 3 comma negative 3. 3 comma negative 3. And then second, find the first initial point. Where is it? Is 4 comma negative 3. Okay, this is my first point. Okay. Second point, 2 comma negative 3. So 2 comma negative 3. So first point is not that accurate. I should say 4 comma negative 3 is here. And third point is 4 comma negative 3. 4 comma -3 is going all the way back. Okay, we'll just say so it's a counterclockwise rotation from initial to this point, and then going back, going all the way to this direction. Okay, this is a counterclockwise orientation. And this is a circle. You can also tell from the equation here. First, I can decide the center, 3, -3. Second, what is the radius? Radius is 1. So from here to here is 1. That means based on this radius, we did the rotation. I can find my graph, and my rotation is counterclockwise rotation. Okay, the following part is some conclusions. Hint to recognize the type of curve. First, if t has a power 1 and power of 1 in both x and y equations, then y is a linear line function of x. If I don't have a squared, and both of the x and y with a t, they are the first power. So this is a linear line. Second, if t has a power of 2 in either one of the equation, then the curve is a parabola. Okay, so the curve will become half of the parabola, square root curve, if the value of t are restricted. We practice this. If both x, number 3, both the x and y are equation of sine and cosine, then look for the coefficient in front of the sine and cosine. If two coefficients have the same absolute value, then the curve is a circle. If the two coefficients have different absolute value, then the curve is an ellipse. There is no chance to have the hyperbola. Do you know why? Because for example, if my sine t squared plus cosine t squared is equal to 1, between them is addition or subtraction. Addition, we never have the Pythagorean theorem, which is minus. So if we have the sine cosine using Pythagorean theorem, between the sine squared and cosine squared is plus. So when we plug in the x and y's value, for example, x, y, or x here, I'm making an ellipse. The hyperbola must have the sign between is minus. So we are not having the hyperbola case in this lesson. All right, have a good one. I think that's the last question of 2.1.